Welcome back to the N4 Learning channel. We're still in the Edge 10 and we're still dealing with our fan coils. Even though it's all completed, we're just going to refine some items there. But I just put a temperature sensor on the input. I think it was input 2 of the Edge 10. It is universal input 2, and it's reading, well, that's wrong. It's set up like this one for a 10K 3A1, but it's not a 10K 3A1, it's a 20K 3A1 that's installed. So I've got to change that now, and I thought I'd do the video showing me changing that. Now normally if it was a Tridium, if it was a ISMA IO, I would just select, and I could select 20K, but I can't from here. So I've got to make my own, well, look at a chart and do the resistors against the temperature. So as you can see, we've got 2.4 kilo ohms, and if you have a look at the resistance chart at the moment, 2.3 is 65, 3.2 is 55, and hence it's in between there. Now we know it's not 65 degrees Celsius here as well, so we know we've got the wrong sensor. So I could either fit a 10K 3A1 and be done with it, or I can change this for a 20K, the resistance chart. So that's what we're going to do. So we're going to adjust this resistance chart. So let me find a 20K resistance chart, and I'll be back in a minute. So here we have the 20K 6A1. It's a Honeywell temperature sensor resistance chart, and we're starting from 0, so we don't seem to do minuses here on this one. Starting from 0 at 71K ohms to 60 degrees at 4.4K ohms. Not too sure if that is the right chart, but that is saying it's a 10K 6A1. Let me go into the controller where it came from, which was Modbus. Yeah, it was there. Let's have just a quick look in here. 22K 3A1. It was a 22K 3A1 sensor. So I need to find a 22K 3A1 sensor, not this. Let me have a look for that. So here we are with the 22K 3A1 now. It's a Johnson sensor, Johnson control sensor. So this is what we've got to put in. But I'm not going to put all them in, but I'm going to just put the odd few in there. Just going to move this to one side, so I still got this screen here, and I want to now select. I don't want to do that one there. Mind you, I could. Let me just export that. Type 3, save. So I've got that there. So if I do screw up with that, I could put that back in again. So I've exported that, so I've got that saved now. So I'm going to go through and put some sensors in. So we'll start with ohms here, 1.5. In fact, let's delete all, add, and let's put that as a 22K 3A1. And let's start with 150395, and that's minus 50. And let's put the end one in, which is 41.61. 41.61, and that is 150 degrees. Okay. Save. So I've only put the first in and the second one in. Okay, well, we know that's wrong. Let's put some closer to the temperature. So 15 degrees is 3539. 3539 is 15 degrees. Add that. And let's go 26 degrees is 2156. 2156 is 26 degrees. Resort. Where are we? 150395. 150395 minus 50. And 150 is 4161. Okay, save. 24.1. Well, we're closer. So I would say I mean, I could go through and enter all these in temperatures in every single line. Let me bring that back across for you now. But I'm not going to today. But what you would do is you bring every line in, and then you could actually save it. So if you ever use a 22K3A1 again, you don't have to start typing all them back in again. So all you would do is export that and save it. And there you have the 22K3A1. It's got it there, 22K3A1. We're going to leave that as it is. Save. But at least we've shown you how to add a sensor that we don't have one that we can pick, so we're using the generic table and doing the resistance and the temperature. So what I wanted to do is expand on the fan coil heating cooling loop, so that when we get above temperature like we are now, even though it's not working, we've got these off, we quicken up the PI loop so that we quickly we don't need to carry on using the same value, 2 for the prop and 1 for the integral. We might as well quicken that up so we can get back down to set point fast enough, rather than using the same standard stages. So that's my next enhancement, let's say. Just makes it a little bit better than, let me just move that, see if I can move that across there a bit more. Makes it a little bit neater control, faster to control is probably the word I'm looking for. So currently we've got a set point of 21 degrees and we've got a control variable 24, so we are cooling, and you can see the cooling coil coming up there. So we've not made set point, so we want to do some logic here so that when that 24 is below 21, we change the proportional and the integral. So let's start with that. So kick. Right, where were we? I want kicked control, and I want maths, and let's do the subtract, and we'll put that into there, that into there. No, we don't want that. We'll go with the less than. And then we'll go with the greater than. So that's cooling, set point reached, cooling reached, set point, rename, heating reached, set point. So we're currently in cooling mode, so we have an and now. So that's going to be one of them, and we want to show that we're in cooling mode. Which we can take that one there, that tells us we're in cooling mode. Also that tells us we're in cooling mode, so we've got two lots here that can tell us we're in cooling mode. So we use this. This is your delta T between your two differential, 2 degrees. So that's in cooling mode. So that's going to be, it's just, so in A is set point reached, and that is mode. Cooling, PI, duplicate that, heating, PI, that's going to be our mode there, and that's going to be our set point reached. So we're not going to get an output from any of them because we're not in that mode. That's fine. So now what we want to do is just move them across there a little bit. Some numeric writables, which I've got some on there. I could have just copied numeric switch, but I'll just bring a fresh one across. Numeric switch, PI, duplicate that, int, so when we're normal, we're going to keep it to a 2, and then we're going to double it to a 4 on the prop, and on the integral, when we're normal, we're going to keep it to a 1, and we'll just double that up to a 2. We can change them later, make them faster or slower. So we'll take that 2 and put it into there. We take that 1 and put it into there. So when we've made set point in our cooling, that's going to enable. When we made our set point in our heating, that's going to enable. So we want to put an OR now. Change PI. Put that into there. Put that into there. Put that into there. Put that into there. And that's it. Should be. Just tidy up a little bit, even though it is a bloody mess. Right, so let's make it so we've made a set point. So set point's 21. We're in cooling mode because we're at 24. So let's put that emergency override. So we'll put that down to 20 degrees. So below set point. That starts cancelling down. And we are now still using 2 and 1. Yeah, we've got that out as a true. That's because we're within the 2 degrees. Now we're in heat mode, so it's never going to work that using that mode there. what we need to do is use that cooling and heating. So let's take that out and use that cooling into the mode. Take that out and use that heating into the mode. Now we've doubled up to 4 and 2, but we're not going down fast enough because there's only a little bit of differential between 20 and 21. If I lower that down more, or put it to 18, it's definitely going to go down faster. Still not enough for me though, so let's put that to an 8. So we'll quickly respond to that, and let's put that to a 4. So hopefully we're responding faster. Naturally, the temperature fluctuation is not going to be as big as what I am doing at the moment. As soon as it gets near set point, so as soon as it's 0.1 over set point, 0.01 over set point, it will start quickening up the PI loop. Now, I just don't like that at the moment now. Why have I got them lot flashing at me? What happened there? And why are we... that's because of the time. We're below now the threshold for the I think it was 50% plus no set point. We have 40% plus 10, so plus 5 either way, so 45, and we're below that. So now I don't have that true, so we can't use that mode there for any of them. So what we can do is add a new logic that if it's a minus, we can put that into there. So we need to change that. So less than if we take that and do less than 0, we can use that for our cooling mode. So we've got, oh, that's jumping around now as well. Why are you jumping around there? Why are you going from minus to plus? Now you've steadied off. Probably need to put some sort of off delay on that. Let's put an off delay on that. We'll put in there an off delay of, let's just try it with 10 seconds. So that's, we're still cooling. Trying to think of different names. I've already used cool. So we want to do the same now for our heating side. So we are currently heating, Yes, we are. Our heating coil's on. We could have actually took that. So we're taking it from our 17 there. We could have actually took it from. We want it really from our 0. No, we don't, because we're not taking account the negative. So anything under 0, we enable that. So what we want is anything above 0. So we do a greater than. Heating. Same point. 0. Duplicate. Heating. Heat. Off delay. So set point hasn't reached yet, so that's not kicking any of that lot in. So we're still sending a 2 and a 1 because we're gradually getting up to set point. So we're gradually opening up that heating coil, trying to get to 21 degrees. So let's put it over 21 degrees now. So we've gone to 20. The actual one would be 20. If we're doing that, 21.01 would actually start it from going back down. Because that is showing now that we're over, but because we're so close to set point, it's not going to just go down like that, like a drop, like as straight to 0. It's not just going to do that. You need to actually go a little bit more. So if I do 21.5 degrees, so we're dropping 15. We're taking our time, but we are dropping, and we're using an 8 and a 4. So we have speeded up our proportional and our integral, but we're still slowly, a bit like a sloth. We're slowly going down. If I actually put that, we've bettered the system, because otherwise we'd still be using a 4 and a 1, sorry, a 2 and a 1, and we would really be slow. So we are quickening up the system once set point is made by changing the prop and the integral. So we are bettering the system by doing it this way. %, 2%. Right, that's now gone false, but there's enough delay there. So they didn't flicker around, did they? We're now in our minuses now, but we won't. That heating coil won't do anything showing a minus. The cooling coil won't do anything until we get to minus 40 plus 5, so 45. So we're back to a 2 and a 1 now, which is what we want. So now, yeah, nothing's going to happen until we get to 45%, and then we start opening up the cooling, because then there's more of a load for it. Okay, we can leave that as it is. We could do a reset on a start. Someone asked me, do I need to do this all the time? And the answer is no, it's just my preference. And all I do there is take a one shot from my timers. reset loop. That would be fine, 0.5, but I just put a 1 there, 1.5 seconds. And then I put that out into my there, and I put my true into there. And all I'm doing is reset. When I enable that, I'm just resetting the loop. So we've got no winding of the loop in case it's running 20. I mean, by rights, if it's running 24/7, but when it starts, it's going to reset. And really, you don't need the reset because it would already be off. So the reset is something, if the loop is running 24/7, never ever stopping, then it might be nice to run a reset once a week. So really, this is rubbish. I just always do it, and I will always continue to do it. But it's really a waste of logic because it's not really going to do anything. If the loop is running 24/7, you're never ever going to have that loop go on and off. And even if it did go off, the reset's already happened anyway, because you switch the loop off and you're switching it back on, so it's already done its reset. The reset here is mainly for when it's been running all the time, 24 hours a day, never turns itself off, and then once a week just send a reset to it to basically reset it. Instead of turning it off and on, you're just resetting it and it's back to normal again. So yeah, it is a waste of a block, but I always do it. So yeah, that's why I'm leaving it in there. I think we've exhausted the loop now and the fan coils. I can't think of anything else we could do. Well, we could make it a bit more intelligent, and we could start doing some forecasting of some days. So we'll look at the weather, we'll look 7 days ahead, we take the average temperature of them 7 days, and then we could probably, in a respite time of in the morning, if it was a heat pump system, we can try and condition the ground loop system so we know we've got more cooling happening. So we want to condition the ground loop system to be better and chuck some heat away. I don't know. But with fan coils, it's just going to be chillers supplying that. So the chillers will work no matter what it is outside temperature wise. So really we couldn't make that intelligent. I presume we could make the loop intelligent. We could do a PI loop AI type of thing to make that intelligent. So we take data from that of what is being running daily, hourly, 30-minutely temperatures, and try and do some sort of calculation. But no, I won't bother with the fan coil. What I do need to do though is I need to put histories on these points, because if I'm going to later on do other items using histories, it'd be nice to have some histories on them points. So I'm just trying to find the points now. We're in the edge, aren't we? So those are my points. Let's go to histories. I don't have that on my kit control. Histories, extensions. We're going to go not change of value, we're going to go numeric interval for the temperatures, and we're going to do it 30 minutes, which I think it defaults at 30 minutes anyway. No, it doesn't, it defaults at 15. So let's do 30-minute intervals for that one. We'll do the same for that one. Save that. Enable that. 30-minute integrals done too. And not bothered about the position where they are. We want to do any sums on that for future to make it more intelligent, i.e. does the cooling valve get to 100%, and if it does, let's record the temperatures when it's at 100%. The same with the heating, and maybe work something with that data. No, I think I'm overthinking it now. Okay, I think that's it. So this is just a little added video onto the other bits, and then we need to start with, once I get some history data, start with this series transform and do a video on series transform for you. Okay, thank you for watching.